It's time to get your arrows popping. Ladies and gentlemen, this is Mr. Whitt with Fort Bend Tutoring, and today's Fort Bend Tutoring tutorial is going to be about solving trigonometric equations, part 1. This is going to be a series of at least 3 videos going over solving trigonometric equations. Matter of fact, the problems that we're going to be doing is going to be right next to us right here. So in fact, let's go ahead and check it out, okay? We have number 1, 2 cosine x plus 3 equals 4. We have 3 cosecant x minus 2 square root of 3 equals 0. We also have number 3, number 4, number 5 that we'll be going over today. So, okay, let's not waste any more time. Let's go ahead and first of all, discuss the workflow of each of the problems that we'll be doing today. So, number 1, we're going to be reading the directions and verifying the possibilities of the solutions. Number 2, we're going to isolate the trigonometric function if possible. Number 3 will be identifying the domain and using substitution where applicable. Let's look at number 4, shall we? Number 4, we're going to use inverse trigonometric functions to isolate the variable. And then number 5, guys, ensuring all solutions are in the correct unit of measurement. Yeah, so that's what we're going to be doing. That's what we're going to be doing. Let's go ahead and check things out, shall we? Here I have a diagram of your special right triangles. I need to use the special right triangles, guys, because I did not purposely, for that matter, memorize the unit circle because didn't want to. Okay, you can call it lazy if you want. No, I didn't. I never to this day. I don't have the unit circle memorized. Thank you. I actually take pride in that. Okay, so do what you want to with that. And so I have for us the 30, 60, 90 right triangle and their ratios. Thank you. I also have the 45, 45, 90 degree right triangles. It's right there. All right, and their ratios. So we're going to be utilizing that to calculate the values because I didn't memorize the unit circle. Thank you. All right, next we have problem number 1, the directions. Step 1. Let's go ahead and solve the equation for solutions over the interval from 0 to 2 pi radians. See, first of all, guys, we can identify the fact that this equation, the results of it, need to be in radians because it's going from 0 to 2 pi. We don't see a degree symbol on the values. So therefore, we can confidently assume they want us to have the solution in radians, and that's what we're going to give them. We're going to start out by isolating the trigonometric function, okay? So let's do that. I'm going to start by subtracting 3 to both sides of the equation. Yes, I will. The 3's will cancel out like so. I'll be bringing down 2 cosine x, which equals 1. From there, my next step is going to be to divide both sides by 2. So that's what I'll be doing right now. Simplify this. We'll end up with cosine x equals 1/2. So since our possible solutions are going to be within the unit circle, meaning from 0 radians all the way up to 2 pi radians, we need to make sure that we're going to identify any angle that when you take the cosine of it will give you a result of 1/2. This is what we're looking for. Next, what I'll be doing is I'll be using the inverse functions to isolate the variables. So I'll have arc cosine of cosine x equals to arc cosine of 1/2. So using the inverse trigonometric function arc cosine, I'll be able to isolate my variable x on the left side of the equal sign, and I'll be able to bring down x equals the angle measurements where cosine is 1/2. That's what we're looking for, guys. So what I'm going to do now is on my Cartesian plane here is I'm going to show that I know that cosine is positive in the first quadrant as well as in the fourth quadrant, and therefore I'll be setting up a triangle to represent that, like so. Knowing that the adjacent side is 1 and that the hypotenuse is 2, and because I'm familiar with my 30, 60, 90 right triangles, I'm recognizing that this must be the result of a 60-degree angle right here. So one angle that generates a cosine result of 1/2 is going to be 60 degrees. And that also means that because it happened in the first quadrant, it's going to also be able to happen in the fourth quadrant as well. So let's set up that scenario in the fourth quadrant, shall we? So in the fourth quadrant, what I'm going to be able to show is that my x value is still going to be 1. My hypotenuse value is still going to be 2. However, in this scenario, our y value is a negative square root of 3 if we should need that information. So our reference angle is still going to be 60 degrees. So we're 60 degrees off of the x-axis, which means that we're at 300 degrees, people. We're at 300 degrees in the fourth quadrant, okay? So that being the case, that means that our solutions here in degrees is going to be 60 degrees and 300 degrees. However, they did not ask for degrees, right? They wanted our interval to be between 0 radians and 2 pi radians. And so that's what we're going to give them. Thanks. So that means that we're going to end up with a solution set of pi over 3 and 5 pi over 3. Yep. All right. So if you need a reminder of how to convert from degrees to radians, go ahead and check out the video. All right. I'm putting the link in here. Okay. So check that out so you can know how to convert from degrees to radians. And of course, we're going to red box our answers just like that, people. You know how we do. Yeah. So that's number 1. That was number 1. Solve the equations for solutions over the interval from 0 to 2 pi, including 0. We end up with pi over 3 and 5 pi over 3, people, knowing that we have the 60-degree angle that was in the first quadrant, and we had 60-degree reference angle in the fourth quadrant, which means we had 360 degrees minus 60 degrees. That left us with 300 degrees. And then converting those degrees into radians gave us a result of pi over 3 and 5 pi over 3. Yeah. Here we go. Problem number 2. With problem number 2, guys, we have 3 cosecant x minus 2 times the square root of 3 equals 0. They want us to write the solutions in radians. They also want us to solve the equation for all exact solutions. Now, this is different from the previous problem because in this example, we are told to give them all of the solutions, not just to restrict ourselves to the unit circle. So notice the difference there. That's very important. Your first step, guys, is going to be to isolate the term with the trigonometric function. So that means I'll be adding 2 square root of 3 to both sides of the equation. Thank you. Alexa, your 2 square root of 3 terms will cancel out on the left side of the equation. Go ahead and bring down your 3 cosecant x. This is going to be equal to 2 square root of 3. In order to get the trigonometric function by itself, go ahead and divide both sides of the equation by 3, people. Go ahead and do that. Dividing by 3. Oh, that is an ugly 3. Oh, you ugly. Why are you so ugly, though? Okay, there we better. A better 3. Somewhat. Now it looks like a duck's mouth. Duck mouth over here. Okay, so the 3's will cancel out. 3's are canceling out on the left side. Simplifying, we'll have cosecant x equals 2 square root of 3 over 3. Now, I'm a little suspicious of the fact that we have this square root of 3 in the numerator, guys. So I want to put it into a format that is going to be recognizable to me, especially if I set it up on the Cartesian plane or if I'm referring to the unit circle or any type of ratios that I'm familiar with. You know what I'm saying? So let's go ahead and rationalize this to see what happens here. Okay. And in rationalizing, we end up with 2 times 3 divided by 3 square root of 3. And the 3's will cancel out to leave us with 2 divided by the square root of 3. So I now have cosecant x equals to 2 divided by the square root of 3. All right, so we're going to set up our Cartesian plane here, and we will notice that our cosecant result here is positive. All right, well, cosecant is the reciprocal of sine. Okay, it's associated with the y value. Our y values are positive in the first and second quadrant. So let's go ahead and make a note of that. So we got the first quadrant here. We have the second quadrant here, people. There you go. So now we want to set up our triangles, all right, in the first and the second quadrant to represent these ratios. Let's check that out. So we'll have in the first quadrant here, all right, got my triangle set up. I know that my y value is going to be the square root of 3. All right, I know that hypotenuse is 2. So because cosecant theta is the hypotenuse divided by the opposite side, we know where the values of the ratio should be applied. And that's what I have here in my setup. Because we have a 2 for the hypotenuse, we have a y value of square root of 3. That means that our x value here, and I'm not referring to the angle measurement of this equation, I'm just saying as far as a Cartesian plane x-axis, y-axis, our x value would be 1, like so. So we're once again dealing with a 60-degree angle here. Okay, so we're at 60 degrees. For the radian measurement, that would be pi over 3. All right, so you can say that you're at pi over 3 now here. Okay, so in the second quadrant now, we're going to be setting up our triangle like so. Thank you very much. And we'll have a y value once again of square root of 3, a hypotenuse of 2, but this time the x value will be -1. Okay, there we go. Once again, you're going to be 60 degrees off of your reference angle here. Is 60 degrees off of the x-axis. So that means that we're going to be at 180 degrees minus 60 degrees. That's going to give us 120 degrees. Yeah. So isn't 120 degrees like 2 pi over 3? Is it 2 pi over 3? I think it's 2 pi over 3, guys. That's an ugly 3. Fix the 3. All right. So we got 2 pi over 3 now. All right. So now that that is the case, we want to solve the equation. Algebraically, we can show that we have arc cosecant of cosecant x equals to arc cosecant of 2 divided by the square root of 3. Your cosecant and arc cosecant are going to cancel out like so on the left side of the equation, leaving us the variable x, and those angles that we identified as being equivalent to 2 divided by the square root of 3 once you take the cosecant of that angle is going to be pi over 3 and also 2 pi over 3. The difference now is that they want us to make sure that we're giving them all of the solutions. So to incorporate every last solution here, you want to add to your result plus 2n pi. All right, that's what you want to add to that. And the reason why we're adding that is because the n is going to represent any integer. So that means that you'll be able to include in your result any coterminal angle, whether it's going to be positive or negative, that will have the same result as pi over 3 or the same result as 2 pi over 3. Okay, so let's put the word and in our solution. So then we'll put a comma and then we'll say where n is any integer. All right, and that's going to give us our result, guys. Red box it. Let's go ahead and put a red box around our answer. Here, well, it's more than the box, right? There we go. There we go. There we go. It's some odd shape there, but you get the gist. So that's going to solve that equation, guys. I guess I should put this in braces for the people. There we go. There we go. Have some braces there. All right, so that was the solution to problem number 2. Let's move this video along, people. So as a reminder, please know that you can set up a paid online tutorial today. That's right, set it up with me, Mr. Whitt. What's up? How you doing? We can be talking about math, about your math problems right now. Why aren't we? Why aren't we doing that? Go ahead and go to fortbendtutoring.com and click on the online tutorials and fill out the form to start that process up. Or you can text 281-536-2019. And back to our next problem, guys. Here we have problem number 3, where it says to solve the equation for solutions over the interval 0 degrees to 360 degrees. So this time we will be writing our answer in degrees, people. There you go. So with that said, I want you to first of all notice that we have the quantity of cotangent theta minus square root of 3 times 2 sine theta plus square root of 3 equals 0. Because these are presented to us in factored forms, you notice that we have a binomial times a binomial equal to 0. We can use the zero product property here in order to solve this trigonometric equation. That said, we can go ahead from the start of this problem, setting our factors individually equal to 0 and then solving for theta. So we're going to have cotangent theta minus the square root of 3 equals 0. We also have 2 sine theta plus square root of 3 equals 0. So with this new setup, we're going to solve for each of the individual equations, keeping in mind that our solutions are going to fall within the unit circle from 0 degrees to 360 degrees. So in the first equation, I'm adding square root of 3 to both sides of the equation, like so. Thank you. The square root of 3's cancel out. They do. We're bringing down cotangent theta equals to the square root of 3. And now we'll use the arc cotangent to isolate our variable theta. All right. This is how it's done, people, just like this. You got it. So now that that's done, we can cancel out the cotangents on the left side, the arc cotangent and the cotangent, which isolates our variable theta, which equals to arc cotangent of square root of 3. So in other words, we're looking on the unit circle where square root of 3 would be the result of us taking the cotangent of an angle within the unit circle. That's what we're looking for. All right. So let's put that on pause for now and go ahead and solve the second equation as well. In the second equation, I will be subtracting square root of 3 to both sides. All right, once again, an ugly 3. This time I'm going to try to fight fixing it. I'll be bringing down 2 sine theta equals to negative square root of 3. Then divide both sides by 2. 2's cancel out. I'm bringing down sine theta, which equals negative square root of 3 over 2. All right, now what we can do is we can use the inverse trigonometric functions to isolate our variable theta. So I'll have arc sine of sine theta. This equals to arc sine of negative square root of 3 over 2. The arc sine and sine will cancel out. We'll bring down theta equals to arc sine of negative square root of 3 over 2. And let's bring both of these results to the next page. All right, guys, so here we have two Cartesian planes. I'm going to use one to set up my theta angles for the first equation, the other for the second one. So for the first equation, we're looking for the arc cotangent of the square root of 3. Remember that cotangent is x over y. So that's how we're going to know our values of these ratios as we plug it in. Also, we're keeping in mind that our result here is positive. So where on the unit circle is your cotangent value going to be positive? That'll be in the first quadrant. It'll also be in the third quadrant that can occur. So I'm going to set up a triangle here showing where theta could possibly be with an x value of square root of 3, knowing that the y value in this case would have to be 1. Why is it 1? Because with a value of square root of 3, if you were to write it as a fraction, you could write it as square root of 3 over 1. So that's where the 1 came from for the y value. Then with that, if you use the Pythagorean theorem, or if you were familiar with your special right triangles, you would know that the hypotenuse would need to be 2. In a case like this, we're looking at an angle measurement, and remember this is going to be in degrees, right? This is going to be a 30-degree angle here. And now to find out what's going to occur in the third quadrant. In the third quadrant, we can set up our triangle here, our right triangle, and we're going to have a value for x that's going to be negative square root of 3. And you'll have negative 1 for y, and once again, the hypotenuse will be 2. The hypotenuse is always positive, guys. So for theta here, we're going to end up with an angle measurement of 30 degrees off of the x-axis. So if we're 30 degrees off of the x-axis, then that means we're at 210 degrees, okay? So we're at 30 degrees and 210 degrees as far as which angles will give us a result of square root of 3 on the unit circle from the range of 0 degrees to 360 degrees. Now, thank you. We're going to be looking at the second equation. And we're looking at a negative value for sine. Well, if this is arc sine, all right, and it's giving us a negative result, a negative ratio, this negative ratio had to occur in either the third quadrant or the fourth quadrant. So in the third quadrant or the fourth quadrant is where sine is negative. If we were to set up a right triangle in the third quadrant, I would have values for y, that is negative square root of 3. I have a hypotenuse of 2, and therefore the x value would need to be negative 1. And we're talking about being 60 degrees off of the x-axis. So being 60 degrees off of the x-axis, we're looking at 240 degrees here. That would have to be at 240 degrees. So because of me recognizing the fact that our opposite value in our right triangle here is negative square root of 3, that's going to line up with the reference angle being 60 degrees. Amen, amen. Now in the fourth quadrant, like so, we'll have our setup. Our y value would be negative square root of 3. Oh my goodness, the ugly square root of 3. All right, so it's going to be negative square root of 3, and then we're looking at a hypotenuse of 2, an x value of 1. Once again, we're 60 degrees off of the x-axis, guys, and that means we're going to be at 300 degrees. Yep, 300 degrees. So now I'm looking at all 4 answers that I have for my solution. So for the solution set for theta, we're looking at angles 30 degrees, 210 degrees, 240 degrees, and 300 degrees. And this is our answer. There you go. Red box it. Just like that, people. Done and done. All right. On to our next problem. Number 4. For problem number 4, we have solve the equation for solutions over the interval from 0 to 2 pi. So for this problem here, I see that our highest exponent on our trigonometric function is to the second power. Before we get there, I'm thinking we may want to substitute, guys. All right, so let's talk to our reader. We're going to say let f equal sine theta. Okay? And if they weren't certain about where I was going with this, I can go a step further. I can say and f squared equals sine squared theta. So after I've discussed this with the people, all right, and who are the people? The people are your instructor, your teacher, your future self. There you go. We just defined a variable that we made up, guys. And we're going to use that made up variable to rewrite the original equation. It is now going to be read as negative 2f squared, which equals 3f plus 1. Let's go ahead and set the equation equal to 0 by subtracting 3f to both sides. And I'm going to go ahead and subtract 1 as well. All right, giving you a little twofer here. The 3f's cancel out, the 1's cancel out. We now have negative 2f squared minus 3f minus 1 equals 0. And with that, I'm going to divide each and every term by negative 1. So dividing away we go. I guess I could have added 2f squared and it would have been simpler, guys, but I didn't think to do that at the time. So sorry for that. Yeah, it would have been easier just to add 2f squared to both sides. Sorry. Didn't recognize that at the time. We have 2f squared plus 3f plus 1 equals 0. Okay? And now we want to factor this, guys. All right? And if we're factoring here, let's take this to, let's bring this over here. We're going to have two sets of parentheses equals 0. We're going to need our variable f. If we multiply 2 times 1, a times c is 2. 2 factors of 2 that add to give you 3 is 2 and 1. So I have a 2 here. I have a 1 here. Thank you. Both will be positive, and then I'm going to divide both of my factors here by 2. Okay. If you need a refresher over that, you can just check out my factoring quadratic trinomials part 2 video, and that'll hook you up. Go ahead and divide both of these by 2 and simplify. You'll end up with your factorization being f plus 1 times 2f plus 1 equals 0. All right. So now it is factored, guys. And with that factorization, we can back substitute our value of f. It's sine theta, remember? So you could write this now as sine theta plus 1 times 2 sine theta plus 1 equals 0. Just like that. Okay, and now that we have it in its factored form, you can use the zero product property in order to solve this. All right, so let's do that next. Setting these two factors equal to 0, we have sine theta plus 1 equals 0. We'll also have 2 sine theta plus 1 equals 0 as well. And from that, we're going to subtract 1 on both sides, like so. 1's cancel out. This is now sine theta equals negative 1. And so, using your inverse trigonometric functions, we'll have arcsine of sine theta equals arcsine of negative 1. The sine and arcsine will cancel out on the left side, leaving us theta equals to arcsine of negative 1. Using your unit circle, you should recognize that the only place where sine is going to give you a result of negative 1 is at 270 degrees, aka 3 pi over 2. So therefore, theta is going to be 3 pi over 2 for that solution. Now we'll solve for the second equation. I'll need to subtract 1 on both sides. The 1's cancel out. I'm bringing down 2 sine theta equals negative 1. Divide both sides by 2, like so. 2's cancel out. You have sine theta equals negative 1/2. So now we'll have arcsine of sine theta equals arcsine of negative 1/2. And then we'll be simplifying, as our sine and arcsines will cancel out. Theta equals arcsine of negative 1/2, like so. Looking at our Cartesian plane here, guys, we know that sine is negative in the third quadrant as well as in the fourth quadrant. So we'll set up both scenarios here. In the third quadrant, our y value would be negative 1, our x value would be Square root of 3. Hypotenuse is 2. So we're going to be 30 degrees off of, this reference angle here is 30 degrees. We'll be 30 degrees off of the x-axis, which means that we're going to be at 210 degrees. All right. And I think in degrees, guys. So that's why I'm writing that down. And then in the fourth quadrant, we'll have y values of -1. You'll have 2. You'll have square root of 3 here. Oh, and sorry, guys. This was definitely negative square root of 3 for that x value in the third quadrant. So once again, we're at 30 degrees off of the unit circle. So you're going to be at 330 degrees. So converting the 210 degrees, you'll end up with 7 pi over 6. And converting the 330 degrees, you'll end up with 11 pi over 6 in radians. So therefore, for this solution, guys, you're going to end up with 7 pi over 6 as well as 11 pi over 6 after converting the 210 degrees and the 330 degrees into radians. So combining all of the solutions together, you'll have the following. Theta is going to be equivalent to 7 pi over 6, 3 pi over 2, and also you'll have 11 pi over 6. All right, done and done. Red, box it. Red, box it, people. Just like that. All right, moving on. So here, guys, I want to remind you to please donate to the channel, as that helps generate more free videos for your viewing and learning pleasure. All right. The donation link is going to be in the description box and on the about page for Fort Bend Tutoring FBT. So check that out. All right, guys, let's go ahead and check out problem number 5. Our last problem. Let's see. We have directions here to solve the equation for solutions over the interval from 0 to 2 pi. So I know I'm dealing with radian measurement using a calculator. All right, well, if that's the case, when I begin this problem, I'm going to notice that it may be factorable, guys, because I'm looking at AC value multiplying the first coefficient times the last coefficient of 12. And can I find two factors of 12 that I add to give me 8? Yeah, I can. So let's go ahead and talk to the reader, shall we? Let V equal tan of x. All right. And, all right, just to make sure that we're clear about that, V squared is going to be equivalent to tan squared x. All right, so talking to the reader, letting them know what we want to do with the problem by creating our own variables and assigning values to those variables. So now I can rewrite the equation as 4v squared minus 8v plus 3 equals 0. Then going ahead and factoring this, I can open up two sets of parentheses like so. I have my variable v, and I'll have the two factors that multiply to give me 12 and add to give me 8. That'll be 6 and 2. Both will need to be negative. And then because of that leading coefficient of 4, go ahead and divide both of these factors by 4 and then simplify. Simplifying, we'll have v minus 3 halves times v minus 1 half equals 0. And then if you want to complete the factorization, bring those denominators in front of the variable to end up with 2v minus 3 times 2v minus 1 equals 0. And this is what we have thus far. Let's go ahead and continue on to the next page. We'll set both factors equal to 0. We'll have 2v minus 3 equals 0. We'll have 2v minus 1 equals 0. And then we will solve for v. Adding 3 to both sides, I'll have 2v equals 3. Go ahead and divide both sides by 2. That simplifies to give us v. We'll have v equals 3 halves. And recall that v is not v. It's actually tan of x. Yeah, we made that up, right? So you'll have tan x equals 3 halves. Then using the inverse trigonometric function arctan, we'll have arctan of tan x equals arctan of 3 halves. And then your arctan and tan will cancel out. Bring down x, which equals to arctan of 3 halves, like so. From here, guys, you're going to need to use a calculator to get this value. So let's go ahead and check that out. So using our calculator here I'm using a TI Nspire CX2 CAS. We're going to type in our arctan. And this is going to be of 3 halves, which is 1 1/2. But we'll make it look exactly as I see it. How about that? We'll go the extra step to make it look exactly like we see it. And it's in radians. All right, let's go ahead and get our approximate value here. And we end up with the value that is round it to the nearest 10,000s. We'll have 9,828 10,000s as this result here. So after ending up with 9,828 10,000s, we realize that almost 1 radian, that's going to occur in the first quadrant. And also understand, as far as the ratio is concerned, having that 3 halves, that can occur in the first quadrant because we have a positive 3 divided by a positive 2. The y value being positive, the x value being positive, puts you in the first quadrant. But you can also have a negative 3 divided by a negative 2 to get 3 halves, couldn't you? So that would place us in the third quadrant. So that means that when we're looking at this situation, we're looking at something like this, that the original setup of that first equation being that we're taking the arctan of 3 halves, this situation can occur within the unit circle in the first quadrant, and I have a diagram in green showing that, and this could also occur in the third quadrant, and we're showing that in purple here. That means that not only are you going to be generating that 9,828 10,000s, you're also going to need to add pi to that value to find out the angle measurement in radians. That'll generate this value of 3 halves in the third quadrant. So let's go ahead and do just that. If we look at our calculator again, so let's take this existing value that we have. Let's go ahead and copy that. Here we go. And let's go ahead and add pi to this value. So adding pi here. And then let's get an approximation. And we end up in the third quadrant with a value of 4 and 1,244 10,000s. So let's go ahead and get that written down. We'll have x could also be equal to 4 and 1,244 10,000s. So we want to keep an eye on this value here as well as this value as well. All right, so that takes care of the first equation that we had solved for. So let's go back and look at the other one. Here we had 2v minus 1, remember? So in solving for this, we'll start by adding 1 to both sides of the equation. Your 1's cancel out. We'll have 2v equals 1. We'll divide both sides by 2, simplifying. You'll then have v equals to 1/2. And remember, v is equivalent to tan of x. So this is tan of x equals 1/2. So what we'll do from here is we'll go ahead and do an arctan of tan of x. This equals to arctan of 1/2. Your tans will cancel out, and x equals arctan of 1/2. Just like this. All right. So now that I have this value now, let's go ahead and see what we can calculate in the calculator. All right. So here in our calculator, let's go ahead and find this arctan here. Here it is, arctan. And let's go ahead and put in 1/2. Remember, just like before, we're going to type it in just as we see it. I like to match my calculator's display to how I have it written. All right, let's go ahead and get an approximation on this. There we go. So we end up with our result, which is 4,636 10,000s, rounded to the nearest 10,000s place. So now that we have that value, that 4,636 10,000s, let's see what this would look like on a unit circle. So once again, identifying that this is 4,636 10,000s. That's our radian measure. And this 1/2 that we were originally looking for, remember we took the arctan of 1/2 this last time, that 1/2 situation can occur in the first quadrant. So let's see here. We could have a y value of 1 and x value of 2, and that very well could be where x is as far as the angle measurement is concerned. So it is this same reference angle of x that we want to generate again in the third quadrant, because once again, what if it was a -1 divided by -2? You would still end up taking the arctan of 1/2. So let's get that set up in the third quadrant, where the y value could have been -1 and the x value could have been -2. So with that, you'll end up with the same reference angle making this occur. So once we have that, then you'll know that you'll need to add pi to this value to generate this. And also keep in mind that the period of tan of x is pi. So knowing that, every n pi radians will be able to generate the same value. So that said, let's take our 4,636 10,000s and add pi to it. We'll have x equals 4,636 10,000s plus pi. Now let's go to our calculator to calculate this value, shall we? All right, so in our calculator here, let's go ahead and grab this value, copy, paste it, and let's go ahead and add pi. Adding in pi, and then getting the approximate value here. We end up with 3 and 6,052 10,000ths. All right, so after getting our value of 3 and 6,052 10,000ths, we're going to keep in mind the 4 values that you see circled here. So that means that you're going to end up with a solution set of, all right, can never get a brace, guys. There we go. We'll end up with the 4,636 10,000ths. We'll also have the 9,828 10,000ths. You'll also end up with 3 and 6,052 10,000ths, as well as the 4 and 1,244 10,000ths as your final answers for problem number 5. Let's go ahead and red box it with a nice red box like that, guys. And this is going to conclude our video on solving trigonometric equations part 1, guys. So there's more to come, so check those out when they're released. And be so kind as to subscribe to the YouTube channel Fort Bend Tutoring. This is Mr. Whitt. Peace.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe.